Dielectric materials. Let us see the introduction for dielectric materials. Dielectric materials are non-conducting materials such as glass, ebonite, mica, rubber, wood and paper. All the dielectric materials are basically insulating materials. The difference between a dielectric and an insulator lies in their applications. If the main function of non-conducting material is to provide only electrical insulation, then we call it as insulators. If the main function of non-conducting material is to store electrical charges, then we call it as dielectrics. General properties of dielectric materials. So we know that dielectric materials are insulating materials. So they are non-metals and they have high resistivity, meaning conductivity is very low. They have a very large energy gap, more than 3 eV. So valence band is here, conduction band is at the top. There is a large forbidden energy gap between the conduction band and the valence band. All the electrons in the dielectrics are tightly bound to their parent nucleus. So no electron is left free in the conduction band. Since there are no free electrons in the conduction band, the electrical conductivity of the dielectrics is very low. Now let us see the basic definitions. First one, what is electric dipole? Let us see the diagram. We have plus Q, charge plus Q, charge minus Q. They are separated by a distance d. So, two equal and opposite charges separated by a distance d is what is called electric dipole. Next one, dipole moment given by the symbol mu. Dipole moment mu is nothing but product of the magnitude of the charge and the distance between them. So magnitude of the charge is q, distance between the two charges is d. Therefore, dipole moment mu is equal to q into d. The unit of dipole moment is coulomb meter. The unit of charge is coulomb. The unit of distance is meter. Therefore, dipole moment unit is coulomb meter. Next, permittivity. We can say permittivity or we can say absolute permittivity given by the symbol epsilon. So this absolute permittivity represents the dielectric property of a medium. The unit is farad per meter. So this permittivity of free space, there is a value which we need to remember. So epsilon naught is equal to 8.884 into 10 power minus 12 farad per meter. So we know epsilon now, we know epsilon naught. So next we have to define epsilon r. So epsilon is nothing but absolute permittivity or simply permittivity of the medium. Epsilon naught is permittivity of free space. So epsilon r is going to be relative permittivity. Usually we write epsilon is equal to epsilon r epsilon naught. Therefore, epsilon r is nothing but epsilon by epsilon naught. So, epsilon r is what is called relative permittivity. Otherwise, it is known as dielectric constant. So, epsilon r is absolute permittivity divided by permittivity of free space. The unit of epsilon is farad per meter. The unit of epsilon naught is also farad per meter. Therefore, there is no unit for epsilon r. And epsilon r value is 1 for air or vacuum. This absolute permittivity, dielectric constant epsilon r is actually a measure of polarization in the dielectrics. So let us see what is polarization in dielectrics. So let me consider this diagram. So let us consider a dielectric slab in between the two parallel plates of a capacitor. We know this dielectric is placed between the two parallel plates of a capacitor. Now let us connect a battery across the two parallel plates of the capacitor. So initially, if we don't apply any electric field, the charge centers are coinciding. That is, positive charge is nothing but the nucleus, negative charge is nothing but the electrons revolving in various orbits. So both the centers will coincide if we don't apply any electric field. Now since we have connected a battery across the parallel plates of a capacitor, we know that an electric field is generated. So because of this, what will happen inside the dielectric slab is the negative charges will be displaced in one direction. So in which direction negative charges will be displaced? Opposite here. I mean plus is here. So all the negative charges will be collected here. And all the positive charges will be collected here because you have a minus here. Negative term of the battery is here. So all the plus will be connected. Will be here, will be near this slab, this end of the slab. So all the negative charges will be displaced here and all the positive charges will be displaced here when an electric field is applied. We know that plus q and minus q separated by a distance is what is a dipole. So we have number of negative charges and equal number of positive charges separated by a distance. So we say that there is going to be creation of dipoles when an electric field is applied. So this process of creating electrical dipoles inside a dielectric by the application of an external electric field is what is called polarization in dielectrics. We will see the next definition, polarizability, and the symbol for it is alpha. So we know that a dipole moment is created and that is purely due to the applied electric field. So how dipole moment is created? Just now we said minus charges, all the negative charges are collected here, all the positive charges are collected here, they are separated by some distance, say d. So there is going to be dipole formation, and because of the dipole formation there is going to be dipole moment. So this dipole moment is going to be proportional to the applied electric field, and the proportionality constant is given by the symbol alpha. That alpha is what is called polarizability. So alpha is nothing but mu bar by E. Mu bar is nothing but average dipole moment of the entire system. So polarizability is defined as the ratio of average dipole moment to the applied electric field. The unit of polarizability is farad meter square. Next definition is polarization vector. Since it is a vector, we have marked the direction. So polarization given by the symbol P. Let n be the number of atoms per unit volume of the dielectric. Let mu be the average dipole moment per atom. Then the polarization is nothing but n multiplied by mu, that is average dipole moment per unit volume of the dielectric. The unit of polarization is coulomb per meter square. The unit of mu is going to be coulomb meter. The unit of number of atoms per unit volume is 1 by meter cube. So coulomb meter by meter cube will give us coulomb by meter square. Next definition is electric displacement vector given by the symbol D. This electric displacement vector is used for analyzing electrostatic fields in the presence of dielectrics. So usually we represent D as epsilon E. What is epsilon? We know it is epsilon naught epsilon R. Also there is another expression for electric displacement vector D, which is epsilon naught E plus P. What is E? Electric field. What is P? Polarization. So there are two expressions which we need to remember for electric displacement vector. One is D is equal to epsilon E and another one D is equal to epsilon naught E plus P. And we know epsilon is epsilon naught epsilon R. So both represent D, that is equation 3 also represent D, equation 4 also represent D. So let us equate 3 and 4. Epsilon naught epsilon RE is equal to epsilon naught E plus P. So I want P. So let me have P on one side. So this epsilon naught E will come to this side. So epsilon naught epsilon RE minus epsilon naught E. So epsilon naught is common. Let me take it outside. Also E is common. So let us take epsilon naught E outside the bracket. So we will be left with epsilon r minus 1. Bring this E to this side. So P by E is equal to epsilon naught epsilon r minus 1. P represents polarization vector. E represents the applied electric field, which is also a vector. So P by E is epsilon naught epsilon r minus 1. Next definition is electrical susceptibility given by the symbol chi suffix E. We know that the polarization vector is also going to be proportional to the applied electric field. Only when we apply an electric field, there is going to be dipole formation inside the dielectrics. Because of the dipole formation, there is going to be dipole moment. So because of that dipole moment only, we are going to have polarization vector. So that polarization vector is proportional to the applied electric field E. So proportionality constant is epsilon naught chi E. So that alone we have to remember. Proportionality constant is epsilon naught chi suffix E. Apart from that, you have this E. So already we have seen P by E is epsilon naught epsilon r minus 1. So actually chi E is nothing but P by epsilon naught E. Instead of P by E, let us substitute equation 5. So instead of P by E, we put epsilon naught epsilon r minus 1. Then we have this epsilon naught. So epsilon naught get cancelled. So we will be having chi E is equal to epsilon r minus 1. So this is the relation between electrical susceptibility and relative permittivity, otherwise known as dielectric constant. So these are the basic definitions when we consider this dielectric materials.